Good morning. I hope you're well. If you're seeing this video, it's because you either have or are considering an Angler 120 PD from Seastream. You're also probably thinking about the same problem I had. We'll get to that. A quick review, others have gone more in depth. It's a 12-foot 3 boat. It's a tri-hull design. It's super stable. I'm 6 foot 230. I've never dumped it unless I meant to, which, by the way, everyone should mean to dump their kayak at least once or twice to make sure you can get back into it and flip it upright. It is about 100 pounds without the driving chair, if I'm not mistaken. I think it's around 120 width, so it's pretty heavy. It's a two-person carry. If you're not quite a bit more fit than I am, and you don't want to carry it real far. Trailer's been great. It's worked out really well. The pedal drive is pretty good. I get 2.5 to 3.5 miles an hour out of it on calm days with no current or headwind. The 3.5 is me really cranking after it though, and it is somewhat loud, but I've not been around other pedal drives to know if it's much louder than something like a native drive. I really don't know. Anyway, it's been a great boat for the 2 years I've got it. But that one problem I alluded to, well, the hull has just one hole that's meant to be opened, and that's the drain hole. There's no access for wiring or storage or anything. The other problem, and this is something I recently discovered as I was doing a more thorough cleaning of the boat, the drain hole doesn't seem to work very well for me. The design of this hole makes it really hard to get water from the front of the boat, and I get water in the front of my boat when I'm going up and down steep hills at the ramps at my house or just through the mountains of the area where I live. It doesn't want to move from the front to the back and out the hole. I had this thing vertical and then tilted towards the drain hole. I let it stay vertical for an hour and then had it tilted for probably 2 hours. Washed it, was wiping it down, then I let it sun dry for another couple hours. And when I started this process, from this front section forward, in the deepest portion of the keel, I still found 1/2 to an inch of standing water. And let me tell you, it smells terrible. That tells me that I've been holding water in this thing, despite draining it after trips, for a long time, and it's begun to mildew a little bit. So I really needed a way to get in and spray bleach or other cleaners to fix that and make sure it's dried out. I also really wanted the storage. Like I said, I'm not a super small guy. You can see I carry a lot of junk in my crate. There's a lot of weight in the back. Anything I can do to move some weight towards the front would be good. Emergency tools, maybe a soft-sided cooler with the drinks you want later in the day but not to hand, your battery, anything like that. Alright, so let's talk about the hull. This is a roto-molded boat, and it uses LDPE. That's low-density polyethylene. You cannot use a high-density polyethylene to weld to an LDPE boat. You must use LDPE. So, if you're going to do any plastic welding for any reason, whether it's repairs or work related to what I'm about to explain, or just fixing gouges, smoothing out the bottom of your boat after a rough trip onto some rocks or something, make sure you've got the right material. That's LDPE. For anyone who's watching this not related to this Seastream, reach out to your manufacturer or check the website to make sure you know what material your boat is. You can weld an HDPE hull with either LDPE or HDPE, but you can only weld an LDPE boat with LDPE. This boat's roto-molded. For those of you who don't know, the quick explanation is you have a mold and it gets rotated just like on a lathe while the plastic is still hot and flowing. What that does is it coats evenly the inside of the mold and forms whatever part, in this case the boat hull. The result of that is you get mostly an even thickness throughout all areas of the boat. Some exceptions, we'll see. And that's actually part of the concern for doing something like this. I couldn't find any videos, write-ups, photos, or anything of anyone adding a hatch to the front or the rear of this particular boat. I could find videos of people doing it to the Shadowcaster, which, when you look, the tank well, the standing deck, and the general shape and design of the boat look extremely similar. My suspicion is they could be from the same master design or master mold and simply have changed hands over the years, which is why the Shadowcaster is not available anymore, but this boat is. I don't know that for sure, but it was my suspicion. And seeing videos of people doing hatches in the rear in the tank well of that boat made me more comfortable doing the same to this boat. I've already cut my hole, so I've got a piece to show you. So you can see the ribs I'm talking about. They're the same in the front or the rear. The hull is nominally about a 1/4 inch thick, it seems. The ribs are about a 1/4 inch tall. I don't know how well this shows up, so move it around, see if the light helps. See if you can see it if I do this. There's negative space under that pencil. You can see right here that the rib did go negative. In that spot, it's only a 1/16 of an inch thick. So since it's only a 1/16 of an inch thick, that's kind of what I was worried about. But for this application, in an area where I don't put a lot of load anyway, the most it's ever seen is a backpack that weighs about 40 pounds for an overnight camping trip, and that spreads across a large area. And I'm doing something else to help reinforce the area. I feel okay about it. I'm going to proceed, but you might not be as comfortable. I understand that, and I have an alternate method you could take to approach this if you didn't want to thin the hull out unnecessarily. It's probably a good option for most people. I personally like this approach a little bit better because it's going to give me a flat surface at the end, whereas the alternate method would have it standing a little bit taller. Probably not a big deal for most of you. Right, so that's the hull talked about and my considerations with it. Let's get to actually putting a hole into the boat. And the hatch I got was just the Amazon special. This one is Smart Marine. It's an 8-inch. It had quite a few purchases and reviews. They were generally positive. In general, I feel like you're going to see reviews for every hatch that says it leaks. And most of those leaks are going to come from around the hatch ring. That's an installation problem. That's not the hatch. The thing you've got to worry about is the seal from this inner piece to the outer. This one uses an O-ring, which looks to me like it's going to work reasonably well. There's a chamfered edge. I don't see anything that's going to cut it. As long as you tighten it, it's probably going to be fine. I'm not too worried. I didn't see a lot of reviews saying that this thing leaked. We're going to go with it. The other thing I noticed, and this is information you're going to want, you need to know how big of a hole to cut. The outside diameter of this lid matches the sleeve that has to go through the hole. So I'm going to take this and make a template to figure out what I've got to cut. And that's what I did. I took it and I found a position that works. Now, when you're choosing your position, there are some considerations. For me, anywhere near the scupper is an absolute no-go. Scuppers, when they are damaged, basically mean your kayak is totaled. They are small holes that go all the way through the hull, so they're very difficult to repair. If one cracks down inside it, you're screwed. If it cracks around the top, you can plastic weld it and be okay. But if you get internal damage, you're in trouble. The other areas of concern are where you transition from the flat to the side, and that's just because it becomes hard to stay flat, and you need a flat surface for that ring to mount well. So I found a spot where I'm basically 2 inches away from the edges, and in this case I'm 4 or 5 inches away from the scuppers. I feel really good about that. Find the spot you want. Generally, I threw a couple marks down, then I got rid of that, and I came to the lid because I know it's the right size. I laid it on top, I traced all the way around it, and that gave me the hole that I'm going to cut. Cut to the inside of what you marked. It makes it where you creep up to the final measurement and get a good snug fit. Once it's marked, you need to cut that hole. Lots of people online have lots of ways to cut holes into plastic boats. For me, I have an oscillating saw. When you're doing this, I've got a flat blade and a curved path. You can't just plunge this in and get a nice smooth curve. It's not going to work very well. You also can't come in at an angle and just follow it if you try to go all the way through. What I did find that works is if you take light passes using sort of the corner, you can guide it around and get a really smooth circle. It took me about 3 passes with how light I did it, and the result was quite good. However, we left ourselves some space because we don't want to screw it up with a power tool. I'm using a small chisel. This one's 1/2 inch. I would have liked 3/4 or maybe even an inch wide, because it would have just made this a bit easier. If this is good and sharp, it works really well. I put the bevel side towards the plastic, the flat side towards the hole, and I'm able to just gently guide this and cut it and leverage. I'm getting really good shavings, and I'm creeping right up onto the dimension that I need. I like this a lot, and it leaves you with these nice curls instead of a bunch of this small, crappy swarf. It's easier to clean up, and in fact, you could probably take a lot of those chips, maybe melt them into the general shape of a rod or a block, and you'll have material for future boat repairs if you need it. Speaking of that, keep this. This is the right material to weld your boat if you've got scratches, gouges, or ever develop a crack on the bottom. This is good stuff. Don't get rid of it. Alright, so we've got a hole now. Again, we want a good tight fit if we can. Mine's not finished yet, so I'm just going to set this on top to show you. Once you have the hole that it goes down inside, you're going to put that down in there and take your marker, and you're going to want to mark the outside diameter against these ribs. The reason you're going to do that is because we have to make a level surface for this to seal against. There are 2 approaches. First, you could add material to make it level with the top of these ribs. That's the alternate method I previously alluded to, because it doesn't remove any material. It's going to give you a thicker, stronger hole, but for me, it's not what I wanted. If you're going to do that, what happens is you're going to end up with this sitting flat to the top of these ribs. Sorry, that might be a better way. So you're going to have, however thick this is, poking up above the rest of the deck instead of being flush. If instead you remove material, it's going to sit down on there, and it's going to be pretty much flush from the top of the hatch to those ribs. That's what I wanted, so that's how I'm approaching it. If you want to add material though, two approaches. The least likely option is that you're going to plastic weld it. I say that because, one, most people probably haven't plastic welded on their boat and aren't comfortable with it, or if you have, like me, you're probably not comfortable doing it in such a large space. And the second is because the risk of deforming the hull means you've got to do some extra things. So, first issue, you've got to heat this whole area, and then you're going to have to plastic weld in to build it up. And it's got to be at least as wide as the flange and as tall as the ribs, and you need it to be watertight all the way from the rib across the bottom and up the next rib. You're probably going to want to build up a mound and then flatten it to get a good flat surface. If you're going to do that though, you're heating this whole area, all of this. So if you don't have something behind this on the inside of the boat when you're doing it, it's going to sag and either make a hole because it gets so hot and sags out, or it's going to mean more material you have to weld in. And as you weld and press in more material, it's going to sag more and more. So you're going to have a backer. To me, that just seems like a lot of trouble and a lot of risk personally when there's a different way you can do it. Especially if you've got a 3D printer, and I'll show you this in a moment. What you could do, I'll just sketch it out. You want to make yourself a circular segment just like that of the correct height and dimensions so that this would match the underside of the hatch. You can use just about any material for that because we're going to bond it in just with marine goop. So you don't have to have LDPE like you would if you're welding on this LDPE hull. You could use LDPE, you could use HDPE, which by the way is available as most cheap cutting boards. So run out to Dollar General, get yourself a 1/4 inch thick cutting board, and you've got material to cut those segments. That's probably how I would do it if I didn't care about having this flush. Cut your segments, bond them in with goop all around so you get a nice watertight seal. Put your goop on here, drop this in, and that's pretty much all you've got to do other than putting your bolts in. For me, what I'm going to do is I'm actually going to create the negative space. I'm going to remove the rib to create a flat surface. Even though it gets thin, I'm not super worried about that. So I'm going to cut this away and make it nice and flat. So whether you're adding material or you're removing, those marks that you make on the ribs, they show you where you need to do that at. Once you've done that, you'll end up being able to set this down in there nice and flat. Now for me, I've modeled myself a backer ring. This is in 2 pieces, so it goes down inside the hull, and then I'm going to assemble it inside of there. It goes around the outside of this ring, and what it's going to do is it's just going to draw up to the inside, and it's going to help spread the load. I'm going to use stainless M5 bolts with washers and nylon locking nuts. That's going to be how I secure it, along with making sure I do a good bead of goop on the underside when I install it. This backer ring, that's why I don't care as much about making that thin. That and the fact that I just don't put heavy stuff on the front of my boat that would deflect and cause an issue. Alright guys, I finished getting this thing cleaned up and ready to fit the hatch, so I wanted to bring you in and show you a few things. So what I did is, you can see I've used my chisel to make this totally flat. I also chamfered each of these edges as it comes down. What that's for is just so I don't have any sharp edges that are going to hang fishing lines or nets or anything I might lay up here. And then I came in here with just some rough sandpaper. I smoothed it out just so there's no real bad snags or real sharp corners or anything. I also got a hold of my goop, so I wanted to show you what that is. That's the marine goop is what you want. This stuff's really good. It's going to hold up really well for our application. I talked some about the materials of the kayak hull itself earlier, and it occurs to me I should probably address the material for 3D printing. PLA is very common, but it doesn't do super well with water or heat. So I actually print all of my parts out of PETG, which holds up much better to water and the temperatures. This is going to be totally fine for what we've got. Also, I went to the hardware store and got what I needed, and turns out I misspoke. Previously I said M5 screws for this particular hatch. These are actually M6s, and they fit much better. I also wanted to go ahead and show you guys from the outside here what the material stack is going to look like. So you're going to have the hatch, you're going to bolt through it, you'll have the hull. I'm going to have this reinforcing ring, which you may or may not have if you choose to do it. And then you're going to want to have a washer and a lock nut. And of course we're going to apply goop between the hatch and the hull, and also in each of the bolt holes as we assemble it. So I'm going to go ahead and assemble this, and we'll show you a final picture here in a minute. Alright guys, I'll bring you along and show you this process. So first thing I'm going to do, I'm going to use some isopropyl alcohol, and I'm going to wipe down any surface which is going to get goop. This just cleans any of the oils off from where we've been touching everything. This gives it the best chance to seal. Just give it a good wipe down. This alcohol dries really fast, so you don't really have to wait all that long for it. It's going to flash right off. You can see on the deck it's already dry. By the time I put this stuff away, it's going to be ready to go. So, got my goop here. I've got my hatch. I've got my hardware laid out where I can quickly grab it. I've got the wrench that I'm going to need to hold it from the back, and Phillips head screwdriver. Everything else I kind of want out of the way. My backing rings are on the inside. One tip for when you're using this stuff is pretty high VOC, so you want to do it outside. It smells pretty strongly. But also, and you can see I forgot to, if you'll take and apply like some Vaseline or petroleum jelly to that, it'll keep it from gumming up. So, first steps, I'm going to mash a small amount down into the negative space of this hatch. This is not the main bead for me. This is just filling up some of that negative space, just so I've got plenty of material in there. And you're going to end up having to use your fingers for this, so just be ready for it. Making a mess. That's kind of how it goes, it seems. It's alright. Alright, so you can see I've got all of those little riblets that were in there. They're all filled. That's what I wanted. Now I'm quickly going to come back here. This is the main bead for me. Right over top of the screw holes. Nice and heavy. I want this super well sealed. I don't mind to pay for the goop. It's not that expensive compared to a boat that leaks. Make sure you're happy with it. Alright. I want it to seal all around. I want it to seal on the inside of this rim and everything. In fact, I might even give myself another quick bead into the neck, the fillet here, this angle. That's what I want. So, we're going to drop it in now. And the first thing I'm going to do, I'm going to grab just an alignment bolt. That's going to go in there. That's going to go in there. That's the alignment. That's that. Now I got to work fast-ish. Fast-ish. I'm going to get... Actually, I got to assemble the backing ring. Can't put it straight on like that. Oops. snapping it together inside of here. You can't see it. It is what it is. That's okay, you might not have one. Depends on how you choose to do this, right? There we go. I'm making a real mess here. This is kind of not how you want to do it as far as making a mess, but such is life. All right, guys, so here it is. Definitely used more goop than I needed to. It was squished out everywhere, made a real mess. Doing this again, there are a couple things I would definitely remember to do. Gloves would make cleanup a whole lot easier. I would also consider coating the top of this rim as well as all the internal threads for this hatch with Vaseline. And maybe even out here on the areas where you know for sure you don't need it to seal, just to make cleanup a little bit easier. But it's really not too bad. You see, if you kind of rub it a few back and forth some, you get it to peel up and you can get it. But there it is, it's secure. It's at least as stiff as it was before modification, possibly even stiffer with that backing ring. And I don't really have any concerns that it's going to leak. I'm going to let it cure a few hours. We'll spray it down, and then, boys, I think I might go fishing. Have a good one.